Okay, chapter 6 talks about the applications of trigonometry. And so we start out with 6.1, which is right triangle trigonometry. And so a lot of y'all will remember this from either geometry or algebra 2, some of it. So let's go ahead and get looking at it. So part 1 here talks about the trig ratios and functions. And so we have this right triangle, and you can see that you got angles A, B, and C. Notice that they're capital letters. And you've got sides A, B, and C. Notice that the sides are the lowercase letters, and they are the opposite of the angle. So like angle A and side A are across from each other. Angle B and side B are across from each other, and angle C and side C are also across from each other. Alright, and so when you talked about this before in your previous math classes, you might have talked about SOH, CA, TOA. And so that helps us find our trig functions of the angle theta. So if you look down here below, it tells us the sine is equal to opposite over hypotenuse. That's where they get the SO. It's a S, the O, and the H. And it tells us that cosine is adjacent over hypotenuse. So that's the CA, the C, the A, the H. And then TOA was tangent, which is opposite over adjacent. So T, the O, and the A for TOA. And so, of course, we know that sine and cosecant are reciprocals of each other. Therefore, reciprocals means to flip the fraction. So we know then that cosecant is going to be the hypotenuse over the opposite. Cosine and secant are reciprocals, so secant would be hypotenuse over opposite, and tangent and cotangent are reciprocal, so cotangent would be adjacent over opposite. Alright, so using that, we can use that to help us solve some of our trig problems, if it's a right triangle. So here in example 1, it says find the exact value for 6 trig functions of the angle theta in the figure. So we want all 6 trig functions. Well, first thing I notice is I don't have all 3 sides, so I need to. So we're just going to use Pythagorean Theorem. So remember that a squared plus b squared equals c squared. And so side A is across from angle A, side B is across from angle B, and side C is across from angle C, and that's the side we're after. So we know that 3 squared plus the square root of 7 squared equals c squared. So we're going to work this out. And so we get that c squared is equal to 16. Take the square root, and c will equal 4. Alright, so when we go to do this, so we have sine of theta. Remember, this is so it's our opposite over the hypotenuse. When you look at your theta there, your opposite is 3, and your hypotenuse is actually what we just found, so I'm going to label it up here, which is 4. And I'm going to go ahead and do its reciprocal. The reciprocal of sine is cosecant. So that means it's going to be hypotenuse over opposite. So it's going to be 4 over 3. And then cosine. Ca. So it's adjacent over hypotenuse. The adjacent is the square root of 7. The hypotenuse is 4. Can't simplify that any further. Cosine's reciprocal is secant. So it means secant is hypotenuse over adjacent, which is 4 over the square root of 7. But remember, we can't have a radical on bottom, so we're going to rationalize that denominator by multiplying times that radical. And so we end up with 4 square roots of 7 over 7. And then tangent of theta, TOA, so it's opposite over adjacent. Its opposite is 3. Its adjacent is the square root of 7. Again, we can't have that radical on bottom, so we need to rationalize the denominator. And so we get 3 square roots of 7 over 7. And then cotangent of theta is the reciprocal of tangent, so it's adjacent over opposite. Now sometimes we shortcut it, and when we say it's a reciprocal, we just take the previous answer then and we flip it, right? But if I had to do work like I did on tangent, I'm not just going to flip that answer. Now if I wanted to flip the beginning of it, I could, but don't flip the final answer, because the final answer we had to do work to get it, and we're going to have to do work to get rid of it then. Alright, so I'm just going to look at my triangle there. My adjacent is the square root of 7, and my opposite would be 3. And so there are my 6 trig functions.